Assalamualaikum and very good morning. Okay, the times now is 8:20. So we can start our lecture, tutorial to discuss topic on space vector. So this is tutorial number 2, okay? Tutorial for the second chapter. Okay, so actually this tutorial, we have 3 questions. So I think the shape of the question is similar. You have 3 questions here, question 1, 2 and 3. Okay. But the question asks you to analyze, to derive some equation of on times to switching all the vectors for 3 cases, for 3 sectors. For 3 sectors. For this case, sector number 2. So remember the voltage vector plane that we have discussed before Raya. First of all, you need to understand how to map all the voltage vectors available or offered in 3-phase inverter. So you have this DQ plane, the direct and quadrature axis, D and Q plane. D is the real, Q is the imaginary. So from here, before you start to map the vector, so you need to derive some equation. So remember the equation is VD and VQ. So you have to derive the equation of to calculate the VD and VQ lah, the direct and the quadrature voltage. So the equation must in terms of switching state. So remember how to derive the equations. So you need to support with suitable diagram. So remember you have the inverter. So you need to obtain the expression of the any phase voltage. So from that, you need to do this substitution, and finally you can get the equation. So the equation must in terms of the state. So you have 6 active vectors, you have 2 zero vectors, where the zero vectors are located at origin. Okay, so actually for the active vectors, when you join all the point for the active, so actually it will form the hexagonal shape, hexagonal locus here. So you can see here. So this is for V1, V2, 3, 4, 5, and 6. So if you join all the vectors for the active vectors, so actually it will form a hexagonal shape. So where the hexagonal, we can equally divide it into six sectors. So each size of sector is 60 degrees. So that's why you have 6 sector, you multiply by 60 degrees, then you get 360 degrees. Okay. Okay, so for the question number 1. So let's say you have the modulator. So this is your modulator. Phase vector modulator. So where your reference, so this case your reference is space vector. Space vector. So I put the superscript star here, indicating that this variable is the reference signal. So the modulator is responsible to produce appropriate switching states. So where your switching states to drive the top switch for each leg. SA for the leg number phase A leg, SB for the top switch for the B phase leg, and SC top switch for the C phase leg. Okay. So this case, your space vector reference is located at the second 60-degree segment of the voltage vector plane. Okay. So this question have 3 parts. So the part A, you need to derive the equations and the on-time equation T2, T3, and 0 time, T0 or T7, in order to switch the adjacent vectors V2 and V3 and the 0 vectors. Okay. So that you can produce the desired space vector. So you need to support your derivation with suitable vector diagram. Okay, in part B, based on the information given here, the DC input, the carrier frequency, and the reference signal. So you have to calculate the on time to switch the vectors involved. Then finally, you need to sketch all the switching state waveform. Okay, how to derive? For this case, you can notice the reference is located in sector number 2. So firstly, you need to identify what are the adjacent vector vectors, adjacent voltage vectors. So this case, the adjacent voltage vector is, are V2 and V3. Okay, clear? V2 and V3. Okay, so to derive, so maybe we need to have space here. Okay, solution. Here, okay, solution. Okay, so for the part A, so this case, the derivation of on time is based okay, so you need to draw the vector diagram first. So you have two axes, remember? This one is beta, and you have alpha. Okay, for this case, since your vector is located in sector number 2, what is the first adjacent vector to be selected? Is it V3 or V2? So remember, before we have discussed this one. So remember, at the beginning of the sampling period, the first vector need to be chosen is 0 vector, right? 0, 0, 0. Clear? 0, 0, 0. Then for the second interval, so which vector need to be selected? V2 or V3? So V3, because we need to minimize the number of switching. Okay, so you have to choose V3 first. So in this case, your V3 will be VA and V2 will be VB. Okay. So V3 is VA, so means based on this axis, so your alpha axis, your V3 vector must be aligned with the alpha axis. Okay, remember? So this is the important step. So the first adjacent vector need to be selected is V3, V3. So V3 must be aligned or in line with alpha axis. So here, so you must draw your V3 here. So this is your, maybe I use different color here, the green color here, V3. So this is your V3. And your V3 is VA. So remember your V3 now here as VA vector. And the first adjacent vector to be selected. So you must draw your V3 vector must be in line with alpha axis, the real axis. Okay, clear? That one is the very important step. Okay. Okay, then another adjacent vector is V2, right? So V2 must, the different angle between V2 and V3 must be 60 degrees. Okay, this one is must be 60 degrees. Okay, so then V2, you can draw like this. So this is your V2. Okay, same length with V3, but the angle for V2 must be 60 degrees from alpha axis and the real axis. So here will be V2, where your V2 will be VB vector. Okay, so remember the angle here is 60 degrees. Okay, okay, then your space vector. So this is your space vector. So your space vector close to V2, this case. So mean you need to sketch your space vector here. Maybe orange color here. Sorry, maybe red color. So this will be your space vector, the reference. Okay. Okay, so the vector involved to produce the resultant vector of the space vector Vs are, so you need to identify what are the vector. So before that, maybe I need to sketch or draw the projection line here first. Okay. Then for then you have this line. Okay, the vectors involved to produce the resultant vector Vs are, so first is, here maybe I use blue color. So this is the vector. Okay. So where this vector, this component vector is V2, right? V2, then multiply by its ratio, right? T2 divided by T. Is it right? And the blue color, component vector with the blue color. So where you need to multiply V2 because same angle with V2, then you multiply by its ratio, T2 divided by T. Okay. And another vector is, okay, so V2 T2 per T. So you can draw the component of vector to here, right? Actually, this is the same vector, right? Where these two component vector are in parallel. Is it right? Okay. And another vector is here. So this is the component vector for V3. Right, V3. Okay. So where this component vector is V3 multiplied by its ratio, which is T3 divided by T, right? You must able to draw the vector diagram here. So of course you have the zero vector at origin. So this is the zero vector. V 07 multiplied by its ratio. T07 divided by T. Okay. So this vector located at origin. So actually to draw the resultant vector Vs, so actually it will fulfill this equation. So mean we can state that, sorry, very good. The vector diagram above is drawn based on space vector definition or equation as So we have the space vector is Vs, right? So where the resultant vector, you want to sketch this vector, the red color here. So actually is the summing of all these component vector. So you have V2 multiplied by its ratio. Then you have V3 and the zero vector. T0 or 7 divided by T. Okay? Where the T is the sampling period, which is summation of T2 plus T3 plus T07. Okay? So we apply these two equations, equation number 1 and equation number 2, to sketch the vector diagram above. Clear? So you must know how to draw the vector diagram in geometrically or properly before you derive the equation. So remember, your derivation must support with this drawing, the vector diagram. Clear? Clear? So in order to sketch or to produce the resultant vector Vs, you need to draw the vector diagram based on these two equations, equation number 1 and equation number 2. So equation number 1 indicate that to produce the Vs, so you need to summing all the component vectors, V2 multiplied by its ratio, T2, T3, V3 and its ratio and zero vector. Clear? So you have these two vector, V2 and V3 here. And the blue color, I draw with the blue color here. Is it blue? Blue or purple? Okay. Okay, then we can proceed because your space vector, you can express into another form, which is into a rectangular form, which is V alpha and V beta, right? So where your V alpha will be here. And so this is your V alpha. So this is your V alpha. And this component vector is your V beta. Okay, so to calculate V alpha, so you need to obtain the component vector here. Maybe this one I use orange color. So this component of vector. So maybe I need to draw first the line here. So mean the different point from here to here. So this component vector, you can obtain as what? V2, right? T2 divided by T, then you multiply by cos 60 degrees. Boleh? So actually you apply in order to obtain the component of vector, the orange color, you need to apply trigonometry function. Focus on this triangular. I need this triangular. I want ni. Okay. So where this angle, remember this angle is mana green color here. So this angle is 60 degrees. So maybe I need to zoom in. Clear? So the orange component vector, so you can obtain this equation by applying the trigonometry function. So remember your trigono, when you apply cos 60 degrees for the green color triangular ni. So actually cos 60 is the ratio between cos, the adjacent divided by hypotenuse, right? The adjacent is ni lah, ni adjacent. Then you divide by hypotenuse. Hypotenuse is V2 T2T, right? V2 T2 per T. Okay, ni this length. The component vector with the purple or blue color here. Okay, clear eh? Senang je. And V beta, how to calculate V beta? So V beta, you apply sine, right? Sine. So maybe I use orange color here where you apply sine 60 degrees. Focus on the same triangular, the green color area ni, where sine 60 is what? Adjacent, this one is opposite. Opposite is V beta. V beta is opposite side of the triangular. Opposite divide by hypotenuse. So hypotenuse same kan, V2 T2 per T. So mean your opposite is V beta, right? So which is equal to V2 T2 per T multiplied by sine 60 degrees. Okay, clear eh? Macam ni. Okay, then okay. So maybe here I write the statement here. Note that Vs can also be written or expressed into a rectangular form. Maybe I need to bring this sentence down here. So your Vs, you can rewrite your Vs as that we have discussed before previously, J V beta. Where V alpha is what is your V alpha? So based on your vector diagram here, so you summing these two component vectors, right? V3 T3 per T, then you summing with the V2 T2 cos 60 degrees, right? You add up these two component vector, this vector and also the second vector here. And then you get V alpha. Okay, clear? So then from here you can write the V alpha equation as V3 T3 per T plus V2 T2 per T multiplied by cos 60 degrees. Okay, since V alpha and V beta are scalar quantities, scalar quantities, it's not the vector, vector unit. So you need to substitute this notation here, V3. So you must write in capital letter. Because V alpha and V beta are scalar quantities. So you just consider the magnetic value. Okay, clear? So then you get V3 and V2. And V beta. V beta. So we have already obtained the equation based on using this function, right? So V beta is the opposite side of the triangular. So where your V beta is V2 multiplied by its ratio T2 per T and multiplied by sine 60. Okay, sine 60. So here V beta is V2, you write in capital letter V2 T2 per T sine 60 degrees. Okay, so this equation, maybe we can write this equation as equation number 3. Here, equation number 4 and 5. Okay, so far okay? Then you need to take into account that, or maybe not that, the magnitudes, manager magnitude, DUE. The magnitudes of vector V2 and V3 are same, right? Because these two adjacent vectors are active vectors. Active vectors have same amplitude. So where the value of the amplitude is, V2 equal to V3, which is 2/3 VDC. So this is equation number 6. So that's why when you map the vectors V1 until V6, so all the vectors have same length, but different in angle. Yeah. V1 at 0 degree, V2 is at 60 degrees, V3 is 120. The length of the vectors are same, but the angle are different. Okay. So then you get equation 1 until 6. So then from here, you have to apply all the equation. Apply equations 4, 5, and 6. T2, T3, and then you apply these three equations 4, 5, and 6. So finally you can write the equation of on time. T2 is V beta multiplied by T. Then you get 2/3 VDC multiplied by 2 divided by sec3. So T2 you can solve for T2 by rearranging the equation where? Equation number 5, right? Equation number 5. Using equation number 5, you rearrange the equation number 5, then you can solve for T2. Yeah. So remember, sine 60 degrees and sine 60 degrees. So actually you can write sine 60 degrees as, is it right? Sec3 divided by 2. Then you substitute, then finally you can get equation number T2 equation. So actually, T2 equation you can reduce further, so that T2 you can write as Z3 multiplied by V beta T divided by VDC. So this is equation number 7. Nampak ni? Okay, this is for T2. Saya akan kecil sikit je. So for T3, to write equation T3, so you have to rearrange equation number what? Number 4. Equation number 4. So remember cos 60 degrees is 0.5. 0.5, half. So then here by rearranging equation number 4, so then you can solve for T3. 2/3 E divided by VDC. Then you have the bracket term, open square bracket here, V alpha E beta divided by Z3. So this is equation 8. Then finally you can write for the zero time taken to switch zero vector, V0 or V7. So T is the sampling period. So you have to take the difference between the total sampling period and the summation of T2 and T3, right? So this is equation number 9. Okay. Okay, this solve for part A, derivation part. Then we move to the part B. So part B, you need to calculate, right? You have to calculate the on time, T2, T3, and T0 for switching all the vectors involved for the given information, where the DC voltage is 96 volt, your carrier frequency is 4 kilohertz, and your reference is 50 volt, and the angle is 75 degrees. Okay, so based on the information given here, so I think firstly you need to calculate the alpha, the angle difference between the space vector and the first adjacent vector to be selected. So what I mean? So you have to calculate the different angle between the reference and VA. So remember, VA is the first vector to be selected, and VA must be in line with the alpha axis, real axis. So means you have to calculate first alpha, the alpha angle. So information given is DS, where the magnitude value is what? 50 volt. 50 volt. Angle is 75. 50 volt. Angle 35 degrees. So means the angle difference here is right. The angle difference between the space vector and D axis, direct axis, is 75 degrees. But the alpha definition, the alpha, because your alpha term you need to use for calculation, the on times. So you need to calculate first alpha. where the alpha is defined as the different angle between the space vector Vs and Va. So remember, Va is the first adjacent vector to be selected. Va is V3. So how to calculate alpha? Someone give the answer. To calculate the alpha, each sector has sector of the vector plane equally divided into 6, right? This sector have same size, 60 degrees. So mean the different angle between V1 and V3 are, sorry, V1 and V3 is what? V1 and V3. What is the different angle between V1 and V3? So you have to calculate this angle first before you calculate the alpha. So of course must be 120 degrees, right? 120 degrees. So means the different angle between V3 and V1 here should be 120 degrees. So from here, you can calculate the alpha. Alpha is the difference between 120 degrees and 75. So what? Apa? What is the value? 45, right? 45 degrees. Okay. So remember, the alpha is the angle difference between the space vector, Vs space vector, and the first adjacent vector to be selected, which is Va. For this case, Va is V3. So that is the definition of alpha. So in order to calculate the alpha, you need to calculate the angle difference between V3 and V1 first. Okay? V1 and V3, the different angle is 120. Then you subtract with the 75. Then you get alpha. Why? So maybe here, for your note, maybe I can define the alpha should be, which one? Where should be your alpha? So remember, your alpha is the different angle between Vs and Va. Here is Va, right? Or V3. So mean the different angle here. This is definition of alpha. Yeah, alpha. Or maybe I can put the note here where your alpha is the different angle. Different angle between V3. V3 is the first adjacent vector, and the space vector reference. Okay. Or alpha, we can define it as a angle within a sector. So where the alpha value angle must be in range between 0 to 60 degrees. It cannot be negative or it cannot be larger than 60 degrees. So remember, your alpha must be in range 0 to 60 degrees. 60 degrees. So that's why we can define alpha is the angle within a sector. For this case, in sector 2. It cannot be negative. It cannot be larger than 60 degrees. Okay. So that is the definition of alpha. So this case, you get alpha is, what is the value of alpha you get? So alpha is 120 degrees, subtract with the 75 degree, then you get 45 degrees. 45. So from here, you can calculate V alpha and V beta. Okay, ini part B. So for part B, to calculate the on times, so this is part B. So firstly, you have to calculate V alpha and V beta. calculate first V alpha and V beta. So where your V alpha is what? Okay, refer to the diagram. Maybe I can redraw. And for simplification, I redraw. You have V alpha here, right? This is your V alpha and V beta to get the resultant vector, which is Vs, right? And the angle difference here is alpha, right? So mean from here you can calculate V alpha and V beta because the angle now you calculate as 45 degrees. The magnetic value of Vs is given, which is 50 volt. 50 volt, yeah, 50 volt. Clear? So maybe I can copy this diagram here to bring to this section. This. Maybe kita resize sikit. Okay. Okay. Okay, so from here you can calculate V alpha as because your Vs. So your Vs given from the question is 50 volt, right? The magnitude is 50 volt, but the angle is 75 degrees. But this case you need to use the alpha, alpha. So mean your V alpha is the hypotenuse value is 50 volt, right? Maybe I can write the magnitude of Vs, right, in capital letter, then you multiply by cos alpha. Is right? And V alpha ni. V alpha. To calculate V alpha, you apply cos function. So where your V alpha, your Vs is 50 volt, cos 45 degrees. Then you get what? 35.355 volt. For V beta, so this case you need to apply sine function. Vs sine alpha. Same value because the angle is 45 degrees, right? 35.355 volt. Okay. V alpha and V beta same values because the angle is 45. Then after you calculate the V alpha and V beta, you can substitute all the calculated value into equation 7, 8, and 9. Okay, sorry. Sorry, then you have to use equations 7, 8, and 9 to calculate on time. So where your T2, 33 V beta, then you get here the value is 3. Okay, this all for part B. Any question? Ada nak tanya? This one very straightforward. So this is for the first case. Maybe to test your understanding, you have to do for the other cases. Case question number 2 and 3. So actually you can apply same process. And the derivation to draw the vector diagram. Okay. Here finally you can calculate all the parameters, the on times. Okay, now part C. Part C, you have to sketch the switching state waveform. Mana part C tadi? So let's see the question first. So in part C, you have to sketch the switching state waveform. A, B, C, S, A, S, B, C for one complete cycle. So you need to include the timing information. I think you just put the label is okay. You no need to put the exact numbers. So in part C, to sketch, so maybe this case I just copy from the notes. But for your case, you need to draw. Snipping tool, new. Sorry. Okay. Then for part C, paste to here. Right? Why cannot paste? Okay, you have to practice how to sketch the waveform, the switching state waveform. So make sure you draw the projection line to draw to divide for 8 intervals, interval number 1 until 8. So then completely label the sampling period T, the waveform SA, SB, AC, indicate also the value where your switching state it can have two values, either 0 or 1 here, 0 or 1. So please completely label the waveform. Then also include the timing information here. T0 divided by 4, T3 divided by 2. Okay. So mean for the first interval, so it need to switch the 0 vector, right? V0, where the combination state is 0, 0, 0. So remember, at the beginning and at the end. Right. At the middle, so for these two interval, so the modulator will choose V7, where the combination of state is 1, 1, 1. So you can see here 1 for SA, SB also 1, LC also 1. But for the second interval here, so the first adjacent vector to be selected is V3, right? So this is the V3. Then it will switch to V2. And here V2, V3. Okay, clear? So this is the way how to answer question part C. So remember to completely label and sketch the waveforms. Include the timing information. So don't forget to put the time information here. Okay, ni part question number 1. So maybe you can try for question number 2 and 3. You try first. Okay, break for 5 minutes, 10 minutes. So maybe you can start to do question number 2 and 3. So please complete the answer before you go out. Before we end our tutorial session today. Okay, so please do question number 2 and 3. All right. Macam tak boleh rehat je. Atau suruh rehat. Question number 2. Đấy. Lebih dari ya. Alamak. Okay, question number 2, class. So what is the first step? So actually you need to repeat for question number 2. So you have to solve for 3 parts, part A, B, and C. Firstly, you need to derive the equations, the on-time equations. So you can apply the same process as discussed in question number 1. Okay, for question number 2, I just copy this solution, question number 1, then bring to here, question number 2. So this is question number 2. So maybe paste to here. Ini apa? Control V. Okay. So you need to sketch properly the vector diagram. Firstly, you need to identify what are the adjacent vectors. So since your vector is located in sector what? Sector number 1, 2, 3, 4. Fourth sector, right? So where the 2 adjacent vectors are V4 and V5. So the first vector need to be chosen or to switch is V5, right? So the V5 will be your VA. And V4, VB. Right. So remember, you have to calculate the alpha. So where the alpha is the different angle between the space vector, the VS vector, and VA. So means the definition of alpha is here. Right? So this is your alpha. So since the first vector to be selected is V5, so you must sketch V5 vector must be in line with alpha axis. Alpha is the real axis. Remember, your V5, you need to draw V5 vector in line with or in phase with alpha axis. Okay? So then from here, you can change. So means here will be your, I just erase the subscript number here. So here will be what? Forgot. V5, right? And the first vector to be selected is V5. So mean your V5 vector, you need to sketch the V5 vector in line with the alpha axis. So mean your alpha axis will be here. So this is your alpha. Beta should be here. And so you have alpha and beta axis. So your V5 in line with alpha axis. V5. So here will be V5. Here, V4. So then you can change also the subscript here. Here will be, right? So the same goes to here. So means here V5, right? V5, T5 per T. This one, V4, right? V4, T4 per T. Then to calculate the orange component vector here, so you have to use the cos function here, right? Cos 60 degrees. So here will be V4, T4 per T, right? And this one, sorry, V beta sine opposite hypotenuse V4, right? Here V4, right? Okay. So I advise you to try to solve from scratch lah. No need to do like this. Just change the numbers. To make sure you apa, practice lah. Practice make perfect. Okay. Clear? So your alpha, how to calculate the alpha? So based on the information given in the question, Where is the information given? Okay, this one. Okay. So here we have defined the alpha, where the alpha is the different angle between the VS vector and VA. So this is your V alpha, right? So where your alpha you can calculate as, how to calculate alpha? Someone give. Can someone explain how to calculate the alpha? The VS angle is 190 degrees. So means the different angle here will be what? 10 kan? Because your V4 angle is 180. So then you have this angle is 10 degrees, right? 10 degrees. Okay, to calculate the alpha, you have to get the difference between what? 60 and 10. Is it right? 60 and 10. Actually, you can calculate alpha as ataupun macam mana ni? 119 or actually you can calculate alpha as okay. You calculate the angle here, right? This angle. What is the angle here? We are use different color ni. The orange ni. To here. What is the angle? You have 3 sectors here, and 380, then plus 60. Oh, sorry, you have 4 sector. Then you get 240 degree, right? So mean the angle difference between 240 degrees, you subtract with the 190, right? Then you get the alpha is 50 degrees. So make sure that your angle must be in range 0 to 60. It cannot be larger than 60 or negative. Okay. So that's why we define this angle as an angle within a sector. Okay, 50. So mean here your angle will be what? 50. Okay, then you apply same process here as discussed in question number 1. Copy lah ni, copy. Actually, starting from here, we just copy. Susah pula. Terus C. Put to here. It means here you need to change the subscript number kan. So now the vector involved is 5 and 4, V4 and V5. So here 4, 4, 5, 5. Here 4, 5. Then mana tadi ni Okay, here I copy for one page here. Boleh ke copy semua? Yes. Okay, for V alpha. So change this number, right? Here, erase first. Okay, from the diagram, vector diagram. So V alpha is you summing these two component vector, V5 T5 and V4 T4 cos 60, right? Okay. B5, B4. So here is 5, 4, 4. For B beta is V4, right? V4, T4 sine. So here is V4 and V5. So same goes to here. V4. V5. V5. For second question, Vs is what? What the value is, amplitude is 50 volt, right? 50 volt, but the angle is 190 degrees. So the angle changed to 190. So then from here, alpha. So remember the alpha. Alpha is what? 50 degree, right? So then you change. Here will be 50. (32.139 volt). Or 5. Okay, boleh. So actually I don't no need to discuss in detail because the procedure kan to solve the question, you apply the same process. So it's better you try practice your own. So this is for the question number 2. So please try for question number 3 to test your understanding. Okay, question number 3. Maybe we can do for short ni, for the important part. The important part to sketch the vector diagram. I think the rest is you have just apply the same process. The important part is to calculate the alpha, to identify what are the first adjacent vector to be selected, and that one. Okay, for question number 3. So this case, your space vector is located in which sector? 1, 2, 3, 4, 5. And sector number 5. So the angle given is minus 95 here. Is it right? 95 degrees. So the two adjacent vectors are V5 and V6. So which one is VA? The first vector to be selected. V5 or V6? So V5. So mean here your VA is V5. V6 will be your VB. So remember the alpha. The angle difference between the first adjacent vector to be selected, which is V5 and VS. So mean your alpha you must define here. So this is your alpha. Okay. So how to calculate the alpha? So where you can calculate this angle first. Mana angle ni? Ini hitam. So this angle the different angle here will be what? 120 degrees, right? 120 degrees. So from here you can calculate, you can simply calculate the alpha. 120 degrees subtract with the 95, right? So then you get alpha is, what is the value of alpha? 25. Okay, remember, so the angle alpha is the angle within a sector. It cannot be larger than 60 and it cannot be negative value. Okay? So remember, you must check your alpha must be in range between 0 to 60 degrees. It cannot be beyond this range. Okay? Yeah. Okay, then you can sketch properly the vector diagram. So maybe, okay, from here, from the original diagram here, actually you can sketch which one is the alpha axis and beta. So the alpha, remember the first adjacent vector to be selected is V5. So mean you must draw V5 must be in line with alpha axis. That is a very important step. If you fail this step, so you can get wrong answer, wrong derivation. So make sure you need to sketch properly the vector diagram. Okay? The first adjacent to be selected, VA. So this case is V5. So you must draw the vector must be in line with alpha axis. Then your beta will be what? Which one? Here will be your beta, right? So this is your beta axis. So remember alpha and beta, the different angle must be 90 degrees, right angle. Alpha and beta, the different angle between alpha and beta must be 90 degrees. So then from here, you can redraw based on the sketch here, then you can redraw. So you have the alpha here, right? The beta should be here. So remember your first adjacent vector to be selected, V5. So you must sketch V5 must be in line with alpha axis. So this is your V what? V5. Okay. Then your V6, the second adjacent vector. So the different angle between V5 and V6 must be 60 degrees. So this is your V6. Boleh dah. So this angle difference is 60 degrees. Okay. So then you need to sketch the resultant vector Vs. So your VS will be here, right? So this is your VS. Then you indicate the definition of alpha. So where the alpha is the different angle between VS and V5, right? V5 and VS. So your VS and V5. So this is the alpha. And alpha. Then the vector involved to produce the resultant vector VS, VR. So firstly, you need to sketch the line here, the projection line here. Okay. So where the component, the first component vector is, so maybe I use the green color here. So where this component vector is V6, right? Multiplied by its ratio, T6 divided by T. So this is the component vector. Then the second component vector to produce the resultant vector Vs is the component vector of V5, right? So means for the green color, V6, T6, you can draw this component vector to here, right? Is it right? These two vectors you draw in parallel. Is it right? So this is the V6, T6 per T. Same vector to here. And to produce the resultant vector Vs, you have to join this component vector, right? So the another vector is, maybe I use blue color here, indigo color. So this vector, the component vector of V5, right? So here is V5 multiplied by its ratio T5 by T. So actually to produce this vector, so you need to apply this equation. So you summing all the component vector V6, T6 per T, V5 here, the blue color ni, V5 per T, and the zero vector, T07 divided by T, to produce the resultant vector Vs. Okay. So you must draw properly. Identify what component vector involved to produce the resultant vector Vs. Okay. So then you can extend your work now to calculate this component of vector. Maybe I sketch first the line, to the projection line here. So remember to produce Vs, so you can rewrite the equation as V alpha plus J V beta. So your V alpha we define between these two lines, right? So this is your V alpha. Okay, clear? V alpha. Clear? Means your this vector from here to here. Okay. Then you summing with the V beta. So V beta is the defined as this vector V beta. To calculate V alpha, so you need to identify or obtain this component of vector. So maybe I use what color? This color, yellow color. Right. Because V alpha, you summing between V5, T5 per T. And this vector, this component vector, apa component vector ni? So you need to apply what? Cost function, right? Cost function. Focus on this triangular. Right. So mean you apply cos, right? So the angle difference here is what? Here will be 60 degrees. Same to here, right? Maybe I need to zoom, magnify the image. Clear? So to calculate this component of vector, so you apply cos 60 degrees. So what? The adjacent, adjacent is the component vector that we need to obtain. Divide by hypotenuse. So your hypotenuse is V6 T6 per T, right? Yeah. Then from there you can calculate the adjacent. So mean this component vector as V6 T6 per T multiplied by cos 60 degrees. So mean your alpha is summing between V5 T5 per T and V6 T6 per T. Jangan gelak. Okay, clear? So then V beta. So how to calculate V beta? So you apply sine function, right? Sine. Sine is V6. Sine 60 degrees. Okay. So make sure this step you okay. Yeah? If you fail to draw properly, you define you give the wrong definition, so you will get the wrong answer for the derivation. Make sure this step you okay. So then you can apply the same process or procedure as discussed in question 1 and 2. Okay. So please do this one at home. Next week I will check your work. Okay. Yeah. All right. You okay? Okay, so for next week, we can proceed to discuss for new chapter. The chapter is topic on Z source inverter. Very simple. So maybe we can try to complete the syllabus for chapter 3. Maybe 1 or 2 weeks. It's okay. 2 weeks. Yes. Next week class. Here at DK1. Midterm. Yes. For midterm, you ask for the midterm test.
Yes.
Okay, midterms. Actually, we will focus only one topic on space vector. All objective question, maybe around 20 question only. 20 objective questions. You just maybe we can conduct here DK1, so you can now in week what? Week number what? Week number 6, right? Here week 6 or 5. Week 6 and maybe week 9, week 8, it's okay. So you can have sufficient time for you to do revision. It's okay. Just objective question. So make sure you understand this one first, tutorial. If you okay, then we can do the test. I think we can do during lecture hour. During lecture hour is okay. Just only 30 minutes. Simple, 30-minute objective question. Maybe I can give a pre-test question before you sit for the test. I can post to WhatsApp group just to see your understanding. Objective question, pre-question, pre-test. Okay. Okay, so don't forget us for next week we can start discuss for the new topic and Z source. Assignment, then we can discuss about assignment. Sorry, the assignment, one more thing. Assignment for SVM. Very simple. Maybe we don't need to do the PCB for this subject. I think we don't have much time to design from scratch, kan? Design the PCB, then soldering. Okay. You just do the simulation on SVM, then you verify your simulation through experiment, and we can apply using this space, a DSP board. I think that one is okay, just enough. No need to do PCB design. Okay, right. Okay, thank you. See you next week. Uninstall.